Welcome to Frictional Force with Ma'am T. In grade 9, Natural Sciences, you were introduced to forces, whereby you defined a force as a push or pull, and you went into classifying the types of forces as contact forces and non-contact forces. Now, when we look at the contact forces, we said that contact forces are forces that act between two surfaces that are in contact with each other. One of the forces that you learned about was frictional force. In grade 10, you went into a deeper detail whereby you defined what is frictional force. And you defined frictional force as a parallel force to the surface that opposes the motion of an object and acts in the opposite direction. The definition still holds in grade 11 and it will still hold in grade 12. Now, in grade 11, we are going deeper. We are now going to be talking about the two types of frictional force and also do calculations for frictional force. Okay, so we have two types of frictional force: static frictional force and kinetic frictional force. You already know what is static. Static means stationary. Static means not moving. Okay, so now when we speak of static frictional force, we speak of a force that exists between two surfaces that are not moving relative to each other. What am I saying? If I have a surface and I have an object on top of the surface, this object, if it's not moving, it's standing still on this object, on this surface, it is still experiencing static frictional force, which is basically the force that's keeping it stationary. Static frictional force is also known as the limiting force. So static frictional force is also known as the limiting force. In order for me to be able to move this object, I need to overcome the static frictional force that exists between the object and the surface. Okay, so if the object is stationary, it does not mean it's not experiencing frictional force. It is experiencing frictional force, and the type of frictional force that it is experiencing is static frictional force. Think about it. If frictional force was not there, if the force that opposes motion was not there, it means that what object will just slide. Do you understand? Then kinetic frictional force is a force that exists between two surfaces that are moving relative to each other. Remember, with static frictional force, the surfaces were not what? They were not moving. Now, with kinetic frictional force, we are saying they are moving, and they are moving relative to each other. By definition, you already know kinetic means moving, in motion. Okay, so kinetic frictional force will exist between two surfaces that are relatively moving. Okay, so it simply means what? Here's the surface, there's an object on a surface. A force is applied on the object, and this object does what? It moves to the east. That simply means what? There is kinetic frictional force and it's opposing the motion of the object. So kinetic frictional force will be going that way, and we are going to call it Fk. Okay, because it has to oppose the motion. If the motion is going to the east, kinetic frictional force must go to the west in order to oppose the motion. To calculate static frictional force, we are going to say Fs. We're saying Fs because we are specifying it is static frictional force. It is equals to Us, the coefficient of static frictional force, multiplied by the normal force. So that is the formula for static frictional force. Then for kinetic frictional force, the formula is going to be Fk is equals to Uk multiplied by the normal force. So the formulas are the same. The only difference is that we put S for static and we put K for kinetic. Looking at our formula, we said that friction is equals to the coefficient of friction multiplied by the normal force. Based on this formula, we can see that frictional force depends on two things. That is the coefficient of friction and the normal force. Okay, now the coefficient of friction is given by the type of surface that the object is moving on. So every surface has its own coefficient of friction, and the coefficient of friction depends on the type of surface. If the object is moving on a tile, the tile will have its own coefficient. If the object is moving on concrete, the concrete will have its own coefficient of friction. It's not going to be the same. Okay, so with that understanding, it's clear to see that if the surface that the object moves on changes, it means the coefficient of friction also does what? It also changes. Right? If every surface has its own coefficient, it means that if the object was moving on a tile, moves from being on a tile and starts moving on concrete, it means the coefficient of friction must do what? Must change. It's not going to remain the same. Okay? Okay. And also remember, the rougher the surface, more friction. The smoother the surface, less friction. Oftentimes when we speak of a smooth surface, we tend to say there is no friction. That truly speaking, there is no surface without friction. So we rather say it is less friction, or at times they can say friction can be ignored. You need to be able to define normal force. You learned it in grade 10. And you defined it as what? As a perpendicular force exerted by the surface on an object in contact with the surface. The normal force depends on the mass of the object. If the mass of the object changes, the normal force also changes. Simply meaning what? If the mass of the object is going to increase, it means the normal force is also going to increase. So now, considering that the force that is being applied on the object acts on the horizontal, the normal force can now be calculated as Fn is equals to Fg is equals to mg. Okay, remember, g is always 9.8 meter per second squared. Let's look at an example. Example 1. This was last year's March paper, 2024 for Northwest. A 50 kg wooden block is pulled across a rough horizontal surface with a force of 500 Newton as shown in the diagram below. The coefficient of friction experienced by the wooden block is 0.7. Okay, so before I do calculations, I like to look at the data that's provided within the statement before I go any further. Now, let's look at it. What's given? I'm given the mass. It's 50 kg. And I'm told what? It's moving on a rough horizontal surface. So definitely there is friction with a force of what? Of 500 Newton. So that is the force that is being applied. Okay. And I'm told what also? The coefficient of friction is 0.7. Okay. Now let's look at the question. Define the term frictional force. Now they are not specifying whether they want kinetic or static. They are not saying that. They're just saying define frictional force. So the definition that we're going to use here is what? Frictional force is what? Is a parallel force to the surface that opposes the motion of an object and acts in the opposite direction. So 5.1 is basically definition that we just stated right now. Okay, guys, forgive my handwriting. I'm using my fingers to write on my phone, so let's not judge. Okay. 5.2. Draw a label free body diagram indicating all the forces acting on the wooden block. Okay, free body diagram, you learned it in grade 10. You learned that what do we start with? We start with a dot. A dot represents the object that the forces are acting on. And we know what? There's always gravitational force going down. It never goes up. Please. Gravitational force always acts down because it is the force that the earth is pulling you towards itself. It is the force that the earth is pulling objects towards itself with. Okay, then our object is on top of a surface, so it means the surface is going to exert a normal force that is going up, and that is Fn. Okay, so because normal force and gravitational force are equal, expectation is that when you draw these forces, they must have equal length because they're equal, but they're acting in opposite direction. Okay, now the force that is being applied towards the east. Okay, so the direction should not change of the force that's being applied. Now, so there's our force applied. Now we need to label it. Because the magnitude of the force is given, I am going to write it down as 500 Newton. Okay, so even if you labeled it as FA, force applied, I'll still make it right. Okay, now I know there is friction that is acting on this object, and I know that the object is being pulled to the east. That means frictional force must go away in the opposite direction. And please keep in mind, frictional force, the arrow is always shorter, and this will be called Fk. So why do you think I labeled the frictional force as Fk? I labeled it as Fk because I'm told the block is being pulled. So if it's being pulled, it means it is moving. So the frictional force that exists between two surfaces that are moving relative to each other is kinetic frictional force. If the object was not moving, I would have labeled it as Fs. 5.3.1. Calculate the magnitude of the normal force. So the formula for normal force is going to be Fn is equals to mg. How much is my mass? The mass is 50 multiplied by 9.8. Please, g is always 9.8. It never changes. So the final answer is going to be 490 Newton up. Remember, normal force is a vector quantity. It has magnitude and direction. 5.3.2. Calculate the frictional force. So the frictional force is what? Is Fk UK multiplied by what? By Fn. So here, it's fine if you just wrote capital N like I did on the previous formula, or you can write it Fn. It's fine. It's still applicable. It's still allowed. How much is my U? 0.7. How much is my normal force? Final answer is going to be 343 Newton, and it will be going left. You can say left or you can say west. It's still correct. And notice something. If my normal force here is wrong, it means that my frictional force is going to be wrong. So please be careful in this situation. The last question of the example. Describe the relationship between normal force and frictional force. Okay, Remember the formula? The formula says F is equals to U multiplied by the normal force. Okay? So what does it tell me? I require the normal force. I require the normal force in order to have frictional force. If I don't have normal force, then I don't have frictional force. Does it make sense? I require normal force to have frictional force. Okay? And also, if the magnitude of the normal force is going to increase, it means that the frictional force is going to do what? Is also going to increase. Let's test it. U is 0,7. If normal force was 1, it means the frictional force will be 0,7. Okay? Then, if I increase the normal force to a 2, it means now my frictional force is 1,4. So it means that as the normal force increases, the frictional force also increases. That means the relationship between them is what? The relationship is directly proportional. Simply meaning what? As normal force increases, frictional force also does what? Does increase. Okay? Please use words when you're explaining this in an exam or a test. Don't do like I did. So normal force becomes an independent variable in this situation, and frictional force becomes a dependent variable. The coefficient of friction, if you notice, it does not have a unit. And the reason for that is because coefficient of friction is actually the ratio. It's actually the ratio of the frictional force to the normal force. That's why it does not have units. Let's look at example 2. We'll be focusing on the coefficient of friction. A block weighing 120 Newton is pulled along a horizontal surface. If it takes 55 Newton to get the block moving and 25 Newton to keep the block moving at a constant velocity, what are the coefficient of friction US and UK? Okay, let's analyze the statement. I have a block. It has a weight of 120 Newton. That simply tells me that normal force is 120 Newton. The block is being pulled along a horizontal surface. They're not specifying the direction, so I choose the right force applied. Okay, it's being pulled. If it takes 55 Newton to get the block moving, so it means that static frictional force is overcome. Okay, so now force applied must be greater than or equal to static frictional force in order for the object to do what? To move. So now F is equals to US multiplied by normal force. Let's correct that. Multiplied by normal force. That means now that means Fs is going to be 55 Newton, which is equals to US multiplied by 120 Newton. So I want US to be left alone that side. I am going to divide both sides by 120 Newton. So cancel. Then I have US is equals to 55 Newton over 120 Newton. From mathematics, I know if I divide two numbers or two variables that are identical, they have to cancel out each other. So Newton cancels out Newton. Then the final answer is going to be 0.46. So US does not have unit because the coefficient of friction is the ratio between the frictional force and the normal force. Let's look at the second part. And it takes 25 Newton to keep the block moving. So to keep the block moving, it means now this frictional force that is acting on the block is kinetic frictional force. And it is moving at constant velocity. So constant velocity simply tells me that F res is equals to 0. And you know that F res is equals to F1 plus F2. If F res is equals to 0, the force that has to keep the block moving is 25 Newton. And I know that frictional force must be in the opposite direction, Fk. Then Fk is equals to what? Is equals to 25 Newton. Okay? Then I can simply do what? I can simply calculate Fk is equals to UK multiplied by the normal force, 25 Newton, UK, 120 divided by 120 divided by 120. Therefore, UK is 25 over 120. I did not include units here because I already explained the units cancel out each other, so there's no need. The final answer is 0.21. Remember, it has no unit, it is dimensionless. Let's look at example 3. It's quite a long one. Let's see how fast we can cover it. A block is pushed and is sliding across a rough surface. The kinetic friction is 25% of the normal force and the mass of the block is 4 kg. 13.1. Determine the kinetic coefficient of friction. Okay, so this is quite easy because the coefficient of friction is the ratio of the frictional force and normal force. And the statement is telling you that the kinetic friction is 25% of the normal force. So that 25% is telling me the ratio. So it means that my UK is equals to 25 divided by 100, which gives me what? 0.25. Okay, easy. 13.2. Calculate the magnitude of the normal force exerted on the block. Normal force Fn is equals to mg. The mass of the block is 4 kg multiplied by 9.8, and my final answer is going to be 39.2 Newton. You can add direction because it's a vector quantity and it's going up. Calculate the kinetic frictional force exerted on the block. So 13.3 Fk, it's UK multiplied by the normal force. So it's going to be 0.25 multiplied by 39.2. The answer is 9.2. 13.8 Newton. Okay, so I'm not going to include direction because I don't know which side the object was being pulled to. So my answer won't have direction just because of that. 13.4. If the static coefficient of friction is 80% or the kinetic coefficient of friction, calculate the static frictional force. So they're saying US is equal to 80% of kinetic coefficient of friction. So 80 divided by 100 multiplied by the UK, which is going to be 0.8 multiplied by 0.25, and then the answer is going to be 0.2. That is the value for US. And now they want us to calculate the static frictional force, which is Fs is equals to US multiplied by the normal force. US is 0.2 multiplied by the normal force. The normal force was 39.2. So the final answer will be 13.5. An identical block is placed on top of the original one. Okay, so here's the original one. It was 4 kg. We're placing another one on top of it. Identical, same material, same mass. Okay. The combination of the block is still sliding across the surface. Okay, so they're not saying anything about the surface changing. So the surface is still the same. Only the mass of the object is going to change. Okay, so A, what will be the kinetic coefficient of friction for this case? Remember, the surface did not change. So UK is still going to be 0.25. B, give a reason for the previous answer. The surface or type of material did not change. The coefficient of friction depends only on the type of material. C, calculate the normal force exerted on the combination of the block. So normal force Fn is equals to mg. So what happened? Our mass increased, so it's 4 plus 4 multiplied by 9 multiplied by 9.8, and our final answer is going to be 78.4 Newton, and the normal force is going up. D, calculate the magnitude of the kinetic frictional force exerted on the combination of the blocks. Okay, so Fk is equals to UK multiplied by the normal force. UK remains as 0.25 and N is now 78.4. The final answer is going to be 192.08 Newton. So it's clear to see that as normal force increases, kinetic frictional force also increases. Okay, because kinetic frictional force or frictional force depends on the normal force. I hope this video was worth watching. Thank you. Please like and share with a fellow learner. See you on the next one.